I give you this example. This looks to be very complicated, but it's not that. We can see it here. We can mark that we have y upon x, 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 we have y upon x. So obviously our substitutions come to be y upon x equal to u. Multiply by ux, we get y equal to ux, and dy is equal to u dx plus x du. We substitute the value of y and value of dy in our equation here. So we get 2x sine y upon x become u, 2x tangent y upon x tangent u, then y is equal to ux into cosine u minus y is ux into secant square u into dx, plus the second term plus x, y by x is u plus x secant square y upon x is u into dy. What's my dy? My dy is u dx plus x du. We substitute here. Now we open this one, we multiply here by dx, with 2x sine u dx plus 2x tangent u dx minus ux cosine u dx minus ux secant square u dx, then multiply here by u dx. We get here u into x du into dx, then we having here x square, x into u into secant square u du. Then we multiply here by x dx, x du, we get here x square secant cosine u du, then we get here x square secant square u du. Now we can see it here, some of the terms are being cancelled. We have here ux, then we get plus sine, ux cosine u dx. You see here ux cosine u with plus sine dx, so they are cancelled. Then we having ux secant square u dx, so this is my term, and this here is the plus term. So these two terms are also cancelled. We cancel this one. Then we write what is left with d. This is left with du, and this is left with dx. So I can take dx common. I can take also x common, 2x common also. I take here 2x out, and I write here sine u plus 2x common. We have tangent u into dx, and then the next term we are going to get here, that is with we take x square common, get here plus x square, and into we get here cosine u plus secant square u into du, and that's equal to 0. So this equation we'll get. Now we try to separate the variables, keeping u on one side and x on the other side. So we can rewrite this one. We taking x on the other one side, we get here du by, we take these x terms to the other side, we get here 2x over x square into dx, and taking u terms to this side, we get here cosine u plus secant square u over, we having here sine u plus tangent u into du. We can see here this is variable separable. Variable separable form, and then we simplify it and integrate that one. We get our solution. We get here 2 outside. We get here dx upon x, and you get the integral cosine u plus secant square u into sine u plus tangent u into du. So simple is the integration we take here is very simple. We get here 2 ln of u, and here I can say this for my z is equal to sine u plus tangent u, and what's my dz? My dz is equal to cosine u plus secant square u into du. So I'll get here dz over z. I get here ln of z. So this will become here ln of sine u plus tangent u, and we take here ln of c as a constant. So we can combine, we can see it here, we get here ln of u square, and there get here ln of c into sine u plus tangent u. We take exponential of both the side. I get here u square is equal to c into sine u plus tangent u, and then we can write here what's my u? What's my u? My u is equal to y upon x. So we get here y square upon x square is equal to c into sine y upon x plus tangent y upon x. Multiply by x to simple x square. Get here y square is equal to c x square into sine y upon x plus tangent y upon x. And this is my general solution. Is general solution. So this I have just given you two substitutions. One was the value xy equal to u, and here I take here the substitution here, y upon x is equal to u, and then I took the substitution x plus y equal to u, and it can be many. It can be different depending upon the problem. So this was the idea that how we can use our substitution to solve the problems for our differential equation. So these were our substitution. I make quick revision of this example again. We're having this differential equation, and we can say we visualize this one, that y upon x is a common value going. So here is a function of y upon x. I put here u is equal to y upon x. So we replace u and then dy by dx also. Y is equal to ux. We transform this one, and dy is equal to u dx x du. Substitute our differential equation and simplify this one. And after simplification, we get here, there must be some cancellation. Here we have the cancellation. Now we have taken this equation and then try to write it. We can see it here, variable separable form. We just shift the values of x on the left and value u on the right, and we can see it here, this variable separable form. So the method of that one is integrate both the sides. So we're having here integration of both the sides, and we simply can write our solution that we are having here by integrating both the sides. Now this is integration. Then as always, I'm advising you the integration that becomes sometime. So here very simple. This is by substitution. This is my z, and then it's my dz. So we get here dz upon z. That's my ln of z. So instead of z, we substitute the value. We get sine u plus tangent u. This is my ln, and I explained you last lecture how to simplify this one. So this 2 become power, and here we can combine this one, mn, and then we take antilog of both the sides, exponential of both the sides. We get here u square and c cosine u, sine u. Put the value of u here. U is y upon x. We get y square upon x square. C y upon x, sine y upon x, tangent y upon x, and y. Sometimes there are the questions looking very difficult like this one, but they are not difficult. If you know the method, you just make the substitution and you get the result.